Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay. So, yeah, last Tuesday we don't have class, right? Anyone can? No? Should I already informed you? Okay, so today we are going to discuss about the third motion. The third motion, which is the general plane motion. Okay, so maybe I will review again the first and the second motion. Okay, so what is the first motion? Sorry?
Linear translation.
Translation, right? So, translation motion. So let's say we have a rigid body, okay, and then we take 2 points. This rigid body point A and B. Okay. So what is the characteristic of the translation motion? All the particles move at the same direction and at the same velocity and the same acceleration. So that's why we can get the equation for the velocity. So Pv will be the same, right? Pa, right? And A, the acceleration of B will be the same as A, right? Okay. So then we have the second motion. What is the second motion? Rotation about fixed axis. Again, let's take this rigid body. For example, this rigid body has a motion rotation about fixed axis. Then point A as the fixed axis, so that when we try to find the velocity of B, and maybe this rigid body rotate, okay, in the counterclockwise with the angular velocity and then angular acceleration counterclockwise. So what is the equation for PV? Omega? Omega cross? R. What R? Distance of AB, right? So R, B, A. From A to B, right? How about the acceleration? Minus or plus? This is counterclockwise. Counterclockwise by rule is positive.
Positive.
So alpha maybe because of the factor of the energy. Alpha cross R A, right? Then plus or minus? Minus
Omega square
omega square R B A. Okay. So this, what is this? Acceleration here? Tangential. And this one?
Normal.
Acceleration here. Okay. Okay. So then, what is the characteristic of the general plane motion? We have discussed this last week. what is the difference of the general plane motion? Combination of translation and rotation of fixed axis. So if that is the definition, it means the equation also will be the combination of translation and rotation of the fixed axis. So in the general plane motion, so in the translation, B and A will be moving at the same direction and same distance, same velocity, same acceleration. In the rotation of fixed axis, A will be fixed, and then B will be rotating, right? Certain velocity and certain acceleration. So in the general plane motion, basically A and B will be having different direction, different acceleration, different velocity. So A may be moving to this direction, B may be moving to this direction. Okay? So that's why the equation will be combination, translation, and rotation about fixed axis. So in simple, you can write down VB as, so what is the combination? Huh? What is the combination for VB? You combine translation and rotation about fixed axis. Huh? You combine this and this. So what is VB? VA?
VA equals to omega
VA plus,
plus
because it's combined, right? Plus omega cross, don't forget cross RDA, and the acceleration
Alpha
AA plus AA plus
alpha
alpha cross R minus omega square R.
VA.
So it's simple, right? So you already know translation and rotation of fixed axis. Then general plane motion is basically translation plus rotation of fixed axis. That is the equation. Okay? So in the book, sometimes they call it relative motion. Okay, it's not it's called general plane motion. Okay, so yeah, maybe you can read the lecture notes. Okay, basically this is more detailed in the lecture notes. Okay, later on you can read. Basically, general plane motion is a combination of translation and rotation. Okay, so this is the schematic view of how the motion of general plane motion. Okay, so for example, at time t, this is the origin position of the rigid body. This is point A and point B. Okay, and then this is the vector position from B from A. Okay, and then at time t plus dt, it moves with general plane motion, so that the rigid body position is like this. Okay, point A become in here and point B become in here. Okay, so it's basically you can draw this as a motion of the translation first, and then after that rotation of fixed axis. So initially the rigid body moved in translation, and then after that rotation of fixed axis. That's why the equation is translation plus rotation by fixed axis. Okay. Okay, so this is the same how to define the position. Okay, so the position of B is basically vector position of A plus vector position of B from A. Okay, with reference to the fixed reference. Okay, so then you can see this is the vector position. Okay, and then displacement also the same. Basically, this is the equation. Okay. Okay. So the rule of thumb in rotation, counterclockwise is positive, remember, and clockwise is negative. Okay. So then the velocity is basically the differentiation of displacement, right? By definition. So then you differentiate displacement, and then you will get this. Okay. And then so then VBA, we have to define what is VBA. So VBA is basically omega cross R. Okay, so this is the equation for velocity for VBA. Okay, so for vector is like this, for magnitude is only R omega. Okay, without considering any direction. Okay, so then this is the equation for velocity, same like this. Okay, and then for acceleration also the same. Acceleration is basically the differentiation of velocity. Okay, or second derivation of displacement. Okay, so then you will get this is the equation. Okay, so it's the same, right? The equation for acceleration. Okay, any question? Hmm? Okay, so this is the equation for velocity and acceleration. The position factor is always drawn from the reference point. Okay, so what is the reference? In this case, the reference is A. So then the position factor is from A to B. Right? So the one that we are trying to find is velocity at. Okay? So omega AB is basically the angular velocity of this rigid body. Okay, because this rigid body consists of point A and B, and then sometimes we write down as omega A. Okay. So normally in the system, it's not only one or it's not only single rigid body. It might consist of 2 or 3 or more rigid body. Then maybe these rigid bodies are connected. Okay, so there will be one point that will be shared by the 2 or more rigid body. Okay, so for example, in this case, we have 2 rigid body. Okay, this rigid body, the yellow one, the first rigid body, and the blue one. This is the second rigid body. Okay, so then they share the same point. So what is the same point? A, right? So A is in rigid body yellow and also in rigid body blue. Okay, so in that case we can find A by using the equation for rigid body in the yellow and also by using the equation of the rigid body in the blue one, so that there will be two equations. Okay, so A from B and A from C. Okay, then the factor position will be AB and factor position will be C. Okay, the same thing for acceleration, because A is shared by yellow and the blue, so we can find A using the equation from yellow and also using the equation from the blue rigid body. Okay, then the angular acceleration also, they will have different angular acceleration. So this angular acceleration for the yellow rigid body, and this angular acceleration and velocity for the blue rigid body, which has point A and C. Okay, it's simple, right? Okay, but how to implement in the problem? This will be the challenge. Okay, so let's take this example. Okay, example 1. Any question about that theory? You can read through again my slide. Okay, if you have any question, you can ask in the next class. Okay. Okay, so let's see this example. If you print from the from last week, maybe this example is in the practical problem. You take in the practical problem. Okay. Yeah, number 1. Okay, let's see this example. Okay. So given block A, so there is a block A, is moving down at 2 meters per second. So this point moving down at 2 meters per second. So we need to find the velocity of B at the instant theta equal to 45. So at this position, theta is 45. It's given, right? Okay. So what is the velocity of B? Okay. So how many rigid body in here?
2.
2.
One.
What is it? Huh? 2 or 1 or 3?
One.
1? Which one?
AM. 2 point.
Huh? 2 point? What is the point?
C. ABC.
ABC is 1 rigid body, right?
Yes.
Okay. So ABC is 1 rigid body. Any other rigid body? No, right? Okay. So when you can see, if point A is moving down, then point B will moving to where? Yeah? To the right or left or up or down?
Right.
To the right. Okay. So this one finished?
Yeah.
So can you guess what is the direction, the vector direction for VB? So if VB is moving to the right, what is the vector? Remember I, J, K. So what is VB direction? Hmm? I. Plus or minus? Plus. I only or J? With J. Hmm?
J and I.
J and I. Why? Just now you mentioned V is only moving to the right.
Yeah, yeah.
So then, what is the vector direction for moving to the right? I or J or IJ? Huh?
ING.
INJ.
Yeah.
INJ or I? Huh?
Yeah.
Remember vector? Okay? Remember vector?
Yeah.
This is I, this is J, this is K. Okay. How about A first? How about A? What is the vector of A? VA. What is the vector of VA?
J.
J or minus J?
Minus J.
Minus J, right? So VA is minus 2J meter per second. And so normally J in the vector you have to give this umbrella, small umbrella. So VB is right. Right, it means
I.
positive I, right?
Yeah.
So you already have the vector, only the number that you need to find. Correct? So how to find that? The plan is that you have to establish the fixed XY direction and draw the kinematic diagram. Then express each of the velocity vector in terms of their I, J, K component and solve VB equal to VA plus omega cross RB. Okay? Okay, so you can see this. This is the XY direction. Okay, this is the XY, and then this is the kinematic diagram. So you have to draw this, and you answer this. Okay, then you put the point. This is point A, point B. Okay, and then if A is moving down, B is moving right, then what is the direction of omega? Is counterclockwise or clockwise? Counterclockwise, right? Can imagine? Okay. So then omega is counterclockwise. Okay? Because it's like this, right? It's moving like this. Right? And then why is A is moving only downward? Because there is a something like the slot, right? B also is moving only to the right because there is a slot in here. So it's like the okay. So this is the solution because we don't know omega. Okay, we only know VA. Okay. So then we use that equation to solve. VB equal to VA plus omega AB. This is rigid body AB cross R VA. Right. So VA we have negative 2 J plus omega AB we don't know. So omega AB K. Okay, because this is the counterclockwise. So you have to put K cross RBA. What is RBA? From A to B.
0.2.
See again 0.2 is the length. You have to define in I and J and K. So what is the component of I? Here. This is the component of I. So this is the rigid body, right? point A, this is point B. So this line is 0.2, and we have the angle 45. So this is 45. So then you have to find the component of I and J. So this is the I. What is this line?
0.2 sine
0.2
sine 45
sine or cosine?
sine.
It's the same, right? Because it's 45.
Yeah.
But then 45 in here, then you can use maybe the sine.
Sine.
Don't forget to put the I. Then what is the J component?
0.2 sine
Plus or minus?
minus.
Minus because it's going down, right? So minus 0.2 cosine 45. Here. Minus 0.2 cosine 45 J. Okay?
And negative 2.
Okay? So remember, this RBA is vector. So you have to define in the vector form. So vector form of RBA, because this is planar 2D, it will be in the component of I and J. So you have to find what is the component in I and what is the component in J. Okay? Any question? Okay? Okay? So this is will be minus 2J
Yeah.
plus
Omega.
now omega
0. And 0.
K cross I.
And 0.
So you see this K cross I. What is K cross I?
J.
J. So what is this? Yeah. 0.2 sine 45 omega AB J. Then how about K? K cross minus J. So it is K cross minus J. Huh?
I.
Get it I or I? K cross J. K cross minus J. Sorry. K cross minus J.
It's I. I is the 5.
I said minus. K. K outside. Minus J is down. So K minus J. So you get I. Right. So then you get I. It means this will be positive. 0.2 cosine 45 omega AB I. Okay. And we know phi B. Phi B is only in J and in I, right? So then phi B is I. Okay? So we have how many unknowns? Huh?
2.
2, right? What is this? Phi B and
And omega
omega AB. So how to solve this? You need two equation. You have two unknown, you have to have two equations. So then you see the component. Okay? So I component. So what is I component in the left side?
I minus
In the left side.
VB.
VB, right? Only VB. What is I component in the right side?
0.2 cos 45.
0.2 cosine 45 omega AB. Then we still have to unknown. Then we need to find the J component. Okay? So J component, what is J component in the left side?
J.
0. What is J component in the right side?
-2
Negative 2
plus
plus
0.2
0.2 cosine 45 omega AB. So then we can find omega AB from here, right? So what is omega AB? Sine. Okay. Yes? 40. 1 4. 1 4 point? 1 4. Radian per
second.
second. So it's correct, right? Power in the factor is 14.1 K. Okay, because this is counterclockwise. How about VB? So then we can find VB. VB will be 0.2 cosine 45 2. So 2. Okay. 2 meter per second in I. Okay? So this is the step in solving the problem related with general plane motion. Okay? So you can roughly predict the direction of the solution. For example, in here, right? We initially can predict that VB is in I. So then the solution also consistent. VB is only in I. Okay? Then you have to find this one, the factor of position. Okay, remember factor of position. It will be in I and J. Then you have to multiple in the cross product with the omega. Okay? Then normally you will find equation in terms of I and J. Okay? Then you need to find what is the I component and what is the J component. From there you can find the solution. The step will be the same for all the problems related with general plane motion. Okay? The equation is only this. Okay? Any question?
Ang tulog rin mo. Ang tulog. Sa langit.